All right, so a more complex example leading on from the previous one where it was a quite simple example where we didn't really need to use the process that we did, but we can. All right, so now here's a complex example where this process does make things a little bit faster, all right, and somewhat easier to work through. So let's have a quick look at the question. It says a transformation is described by the equation here. So this is a transformation. So let's just explore that for a second. It says that we've got a variable or an equation. All right. Now, plus b means that we're translating it first, then we're going to dilate it or reflect it or do whatever, and it's going to then be an image. All right. So this is the order of operations given to us here by the brackets. So this has got translation, then dilation. All right. The question then goes on to say that this is the transformation matrix used. This is what the translation is. So this is, it's 1 unit across and 2 units up. This one seems to have a reflection across the line y equals x and then some dilation from there. All right, so it wants us then to find the image. This is the x image of the straight line here. All right, so you can see some similarities to the previous one, but we need to find out the image. Okay, so first of all, we're going to take this equation, plus b, sorry, equals image. Now we're going to isolate x. So I'm going to undo everything that's been done to x one step at a time. So the first thing is to multiply by the inverse, because the brackets have been done first, so they have to be undone last. All right, so multiply by the inverse. That's going to get rid of, and the inverse on this side also. For those who are wondering why we multiply the inverse, sorry, no, that's not -1, it's just that. We multiply the inverse onto the left. It comes from function notation, and I could explain that later on. But for now, you just got to remember that it won't work the other way around because of the multiplication of matrices. All right, so x plus b equals the inverse times the image. So then I'll subtract b from both sides, minus b, so I end up with x equals the inverse times the image minus b. All right, now we can just go and substitute what we know in place of these three things here. So we have x equals now t, the inverse of t. We're going to have to find out what it is. So let's go over to here. So it was 1 over those minus those, so 0 plus 6, because 2 times minus 3 is a minus, and minus a minus is a positive. We swap those two, so they're still 0, and we make these two the opposite of what they are, like so. So then I have 1 over 6 multiplied into each element of the matrix, and I end up with 0, 1/6 of 3 is a half, 1/6 of minus 2 is minus a third, and 1/6 of 0 is a 0. So the inverse matrix is this. The image point matrix is this. Oh, not plus. And the translation matrix is this. All right, and now it's just a matter of calculating this out and simplifying as we go. So I have multiplying rows by columns is going to be 1/2 y image. Rows by columns is going to be minus a third x image minus the translation matrix. I keep putting a fraction sign in there, you don't need to. And so the final thing is going to be 1/2 y image minus 1 over minus a third x image minus 2. All right, so this is the original point, like so, here. Interestingly, if you remember at the start, I told you that this transformation matrix seemed to have a reflection across the line y equals x. We come to do this later on, but have you noticed here that the x value now equals the y value, and the y value now equals the x value? And that is a clear sign that the line has flipped across the diagonal line. Just to show you what it means, here's the line y equals x, and anything on this side has now reflected straight across to this side, And the giveaway to that is that the x and y values swap positions. So for this one, I've got x equals 1/2 y image minus 1, and I've got y equals minus 1/3 x image minus 2. And then it's just a matter of substituting this and this into these positions in the original equation, which was 2x plus 5. So I've got y equals 2x plus 5. Where it says y equals, I now put the x, or what I found out as y equals 2 times 1/2 y image minus 1 plus 5. Simplifying and rearranging will give us minus 1/3 x image equals y image minus 2 plus 5 plus 2, because I moved this minus 2 across as a plus. So minus 1/3 x image equals y image plus 5. And then I'll rearrange, move the 5 across to the other side. So minus 1/3 x image equals, oops, missed the plus 5, minus 5 equals y image. So then this is the equation of the new line after it's undergone the transformations given by this transformation matrix and that translation. All right, so you can see that this process does make it a bit easier in complex examples where otherwise you'd have to muddle through what each transformation was doing, and then the order comes into it and it can make things a bit messy. All right, so it's really it makes a complex process rather quite simple, and you can see that the end result is what we thought it should be. Okay, and I would encourage you, the first step you need to work on is this step here, where you're creating, or if they don't give them to you, or using what they gave, but in equations that use variables, and then when you've finally got it to how you want it to be, substitute in the matrices. Okay, so to recap, we need to identify the parts, we need to work with the equation they gave us, we need to rearrange it before we substitute matrices in. It should be in place of x equals, but you need to read the question very carefully. Then we need to substitute the matrices in, simplify, multiply, simplify, and substitute what we find for x and y back into the original equation and simplify back down to a form that we want, or form that we use regularly.